feedback? That was good feedback. What the heck is that, Scott? Can you hear me? I don't think this is going to work. I can't hear you, Scott. I didn't hear anything on the video you were playing. Before that, I was getting really horrible feedback. Did you hear that? No. This is twice in a row, Scott. I'm getting this. I'm starting to think you don't like me. I guess I should go ahead and introduce the show while you're busy trying to fix that. So, hello, everybody. This is Scott Roberts with the OpenGOTO community episode today. I'm going to be talking about a couple of things on the forum that we've had questions about. Scott's going to be talking about the Global Star Party tonight. It's and this is OpenGOTO community show. I think you said it was 145. Is that right? You can just put it. I don't know. I think it's number 145.
Did that fix it?
Yep, I can hear you now.
I just cannot hear Jerry. So.
Once you get it, can you not hear me?
Okay.
Can you hear me now?
Thank you.
There's a little bit of an echo from you, I think.
Let me check something.
I want to welcome everybody to the pre-show checkout.
Okay, gotcha. All right, here we are. I don't know why everything got switched around here.
You've got a little bit of an echo, or a little bit of a echo in the background when you.
Yes, I know. How's that?
I can still hear it. I don't know. It's fine. I mean,
Scott's in the bathroom.
It's not. Yeah, it sounds like you're in a little echo chamber, but it's probably okay.
Driving me crazy. Okay. Anyhow, I will. I think what I'm going to do is reboot everything later, but we'll get through this show here today.
No, you sound good.
Do I sound all right? Okay.
Yeah, you sound good. Just a slight echo. That's not a big deal, I don't think.
Okay. Kind of the Scott given the broadcast from the shower or something. So anyhow, I did want to give, just a big shout out again for everybody that participated in the Saturday's Global Star Party, including David Levy and Doug Berger and, the guys from the Royal Astronomical Society of the Montreal Center. They were just great. So they had a bunch of people on. It was fascinating. Yeah, I thought very high quality, and we had loads of fun. So that's the main point. Replying to Explore Scientific. Hello, my beloved. I have a message for you. Okay. Thank you for all the love. But tonight we have another Global Star Party, and Dave Eicher will discuss, of all things, the meaning of life in the universe. So, if you guys have been searching for the meaning of life, I know I have, this is going to be a really cool one. Of course, David Levy will be on. We also have Don Sell. He'll be on the program from the Texas Star Party. Don is given like astrophotography workshops and stuff, but he's going to talk about Texas Star Party a little bit with us, which is coming up this June. And you will see the virtual Texas Star Party actually broadcast live on our Facebook pages. So I think that'll be very cool. And what else can I add for right now? We still have, our cell phone astrophotography contest is still going on. So if you haven't turned in any images yet, you'll want to. And that's I think that's all I have. Beatrice wants to know, how late is the star party today? Maybe it was already said, but I missed it. We will start at Universal Time at 1 a.m. So that's maybe the best information I can give you, Beatrice. But in the meantime, let me give you, let's talk about the people who are online with us. Book Davies was the first to log in, and then Richard Grace. We got Jeff Wise with us. Who else? Cameron Gillis.
Cameron.
Be on the Global Star Party tonight. Pekka Haltala will also be on Global Star Party. We hope to have some others on. Martin Eastburn is with us. Howdy all. Looks like many are back already. Who else?
I'm going to try to be on there. I think what I'm going to do, since the moon has got first quarter, I'm going to try to get
That'll be nice.
some first quarter moon images.
And by the way, everybody needs to get ready for the lunar eclipse. I showed a couple of visualizations from NASA on the path of the eclipse and also what it will look like during totality. Aaron Thompson is on with us.
Hi, Aaron.
Yep, Pekka's watching. Pekka says, one more reason to come quickly to the USA. That's right. Norm Hughes. And I think that's our group. I mentioned Pekka and Beatrice and Harold Locke. He hears you, Jerry.
Sounds like the regular cast of characters that we have.
Yeah, Aaron Thompson's watching. Yeah.
Good.
Yeah, it's nice. It's nice. It's good. Lots of good chat.
I have an easygoing show today.
Meeson is on. That's someone new.
Oh, welcome.
Yep. And that's all I see for right now, but that's a nice group. So, and Wallace Ronald Delvaux. Yeah. So
Ron Delvaux, yeah.
Yeah, Ron. And Chuck Lewis is watching. Hello, Chuck.
Oh, Chuck, how you doing? I've been working with Chuck lately.
Have you?
Yeah, on the firmware.
Oh, very good. Very
testing some things. We just corrected a little minor thing that he was good to help us with, and I want to also thank Jenny Shelley. She's not on, but I think I talked about this last time, correcting a problem, and crap, I can't remember. We have another person that helped us with that problem, and I can't remember what his name is now. I apologize. I'll find it before and help and thank him again. But it's working. I think it's working pretty well now. I mean, I've been saying that, of course, but having people. That's right. It's cool though that we have customers that will report bugs when they happen. It's always nice to.
Yeah.
The worst thing for anybody that takes care of equipment is to have somebody suffer with an issue and not tell us about it. We don't want them to suffer with an issue that's a pain in the butt, that makes them hate us.
Well,
we don't want that at all.
Anyone who does software will run into fixing bugs. Okay, that's just normal. Okay, but what I find is very gratifying is how quickly we jump on it and we take care of it. And I can't. We're going to be the last people to say that we don't have faults or we don't have issues, but we're always right there to be transparent about it and to take care of it. That's our job. So
yeah, I think it helps to be as transparent as you can be and tell people, yeah, this is an issue, and right. You'll run into it, and not everybody runs into it. Sometimes it takes special conditions or special cases, to find it, and that's why these bugs that we've been locating since we released it were really intermittent type bugs that didn't happen, except under very specific circumstances, and you had to really almost pound on it to get it to occur, you know. So
Yeah.
those are the things that are the best things for us to fix, because but then we, you know, we know we're nailing down the little minor stuff at that point.
Right. Yep, and so that's cool. So you mentioned there was a couple of things on the forums you wanted to talk about, Jerry.
Right. So the first one, there's been some, and this is an ongoing issue when people are new to the POTH, new to the ASCOM driver settings and stuff like that. We always tell people to use the POTH hub to be able to communicate with different ASCOM clients with our mount system. And the POTH's got hand controller built into it, but this hand controller operates a little bit different than most people expect. And I'm gonna I think I'm gonna share my screen and try to demonstrate it a little bit if I can.
All right.
I'm going to share my main display. So I've got, do you see the POTH here at the bottom left?
Yeah.
Right now I'm pointed to an object, new, what constellation is this? Anyway, basically this, so when you move the mount manually, okay, I'm going to zoom in really good. So for reference, this little circle that's around this star, Eta Leo, is 1 arc minute in diameter.
Okay. That little circle in the center?
The circle right here is very tight, okay? And this is, so when I slewed to this object, this is where it positioned the mount. And of course, this is all the electronics thinking it's where it needs to be and where it puts it, but you've got a little bit of mechanical slop, I should say, that gets you close to this, but it depends on your mount and everything else. So the G11 is going to perform different than the Exos 2, which is going to perform a little different than the iXos 100 in terms of go-to performance. But overall, the electronics should be near perfect. Okay. But having, so what I'm going to demonstrate here is the way the buttons work on the POTH. So if you look here, I can select different rates and different jogs. So there's two different things you can select. You can select a rate or a jog. The issue comes in when you do a jog, okay? So if I want to jog the mount, let's say 10 arc minutes, okay, I've got it selected to 10 arc minutes, and this is a jog, and I move it, let me zoom out just a little bit, and I move it, let's say I move it east 10 arc minutes, okay?
Okay.
So you just click on the button, the E button, and just click it. You don't have to hold it down or anything, and it'll move. It should move 10. Actually, I want to move the coordinates to the equatorial coordinates so you can see that it moves east, west, north, south. So when I hit the east button, it should move 10 arc minutes to the east. So let me hit it. And you see that?
Yeah.
So it moved to the east 10 arc minutes. Now, when I move it west 10 arc minutes, it should go back to the star. All right.
Right.
Let me, I guess it,
Well, it almost went to the star.
It almost went to it. Let me move it again.
Are you moving it 10 arc minutes?
Yeah, it moved it. Okay, there.
Oh, I see. It just took time to resolve.
Well, I don't know what happened with the communications. Anyway, so let me move it north.
Okay.
See there? Then I'll move it south.
Okay.
Come on. That's interesting. Let me move.
It's moving.
Yeah, there it goes. Now, one thing, there's a couple of behaviors that we're noticing here. So when I moved it north and south, You notice that it drifted a little bit in
Yeah.
RA while it was moving. Okay, so what happens is the controller, when it moves north or south, it's not tracking. When it's doing a manual move like that, it's not compensating for the Earth's rotation.
Right. So that's in the time that it took for you to do that command and move, that's how far the star moved.
Right. Right, exactly. So that's something to keep in mind. Okay. Now, when we do a slew to an object, I do calculate the time it takes for the slew to calculate the endpoint on the slew and to make sure I compensate for the Earth's rotation also. So if I were to, let me zoom out here, and I'm going to slew to another star just to give you an example of that. Let's move over here. I'm going to center on that star, and I'm going to hit the slew button.
So Harold Locke has a comment. He says, "My big issue is when will astronomy go-to systems drop having to have any kind of COM port assignments, virtual or actual, and go to USB only?"
Well, the thing is, all devices communicate serially. All right. USB is a universal serial bus. It's still a serial.
That's what
It's
the
still
S
a serial
means, is
device. That's
serial.
what S means, serial. Now, there's different ways to configure a serial. So, for example, the IXOS 100 has a USB connector. Okay. It uses a USB driver. But in order to communicate with it with a program, you have to connect to it somehow, and it's always assigned a COM port. Okay, a virtual COM port, and that's the way we communicate with a universal serial bus. Is we assign the device to a COM port, and that's just the way you communicate with it. So in terms of assigning it a COM port, in that regard, that's just the way it works. At some point, there may be another type of system that they develop, but legacy support is very important in computer systems, even if you don't like it. I mean, we have Wi-Fi, so Wi-Fi, even the Wi-Fi module that we use in the IXOS 100 and the G11 and the XS2, it comes in Wi-Fi, but it gets converted to a serial communications. Okay. And that's the way we treat it in terms of the coding. It still has a baud rate. It still has a even though it's transported over a different media, the media is Wi-Fi instead of Ethernet. It could be Ethernet media or Wi-Fi media. It gets converted to serial at the bottom, at the endpoint, at the end of it. So even so, the FTDI chip that we use in the IXOS 100 that connects to the USB connection on the computer, it comes in as USB, but it goes out as serial.
I see.
So that's just the way it is. So there's no getting rid of serial buses or serial communications. That's a fundamental communications. So what I want to demonstrate now is where the issue comes in with the POTH. I'll park the mount, and this is where the issue comes in. So when I park the mount, it'll go to the North Celestial Pole. I'm going to zoom out a little bit, and I'm going to wait for it to get there. And I'll go ahead and track telescope so you can see where it's at. You can see it's sliding across the chart. My daughter's coming in. That's why my dogs are barking.
I think you have like a button that you press and the dogs bark.
Oh, it's just a sound effect, like the sound effects you have with the applause and stuff.
Right.
It's a dog barking sound effect. All right, so now I'm at the North Celestial Pole. All right, and there's Polaris right there, Alpha Ursa Minor.
Okay.
And so this is a quiz, right? So what direction can I move the mount from the North Celestial Pole? What's the only direction I can move it?
South.
That's valid. That's right, south. So I'm going to unpark it and turn tracking on. Now, what happens if I try to move it north? Theoretically, it won't move, right?
If you're at north.
If I try to move it, so for example, I've got the pulse set to 10 arc minutes to jog it. So if I try to move it 10 arc minutes north,
it's going to move south.
You think it'll move? Is it smart enough to know that it can't move north, or will it?
Well,
just
it
move
might
south?
be smart enough, but it's not.
Well, we'll see. Let me hit north. And
I
see
don't
what it
know.
does.
Let's see.
All right, so I'm going to hit it.
Maybe it is.
It didn't move.
Didn't move.
See the declination still here? It says 90 degrees.
Yeah,
on the
it is smart.
So let me move it south and let's see what happens.
But if I move in any direction in declination, it's south, right?
That's right. Now it did move. That's interesting. It moved a little bit. I don't know why it's not moving 10 arc minutes. Let me select a bigger move. Let me move 1 degree. Okay, there it goes. All right, it moved 1 degree. Let me park it again. I'm going to park it, and then I'll do it again. All right. Yeah, unpark it. So I'm going to move it 1 degree south. All right. Now, what the path is actually trying to do, and this is the source of the issue, is that it tries to move it relative to azimuth and altitude. So if you want a 1 degree move down or south from the North Celestial Pole, it'll do that. Now, if I try to move it east or west 1 degree, it won't it'll try to physically move it sideways 1 degree, right? Or you would think it would try to move it 1 degree sideways in azimuth, right? East or west.
Yeah, but we're in equatorial mode.
Or an equatorial mount. So the only way the RA axis can move is around the North Pole, right? It can't move directly west. It looks like west, and it is west or east in the equatorial coordinate, but it's not east or west in the azimuth coordinate. Okay, so when we try to move east or west in the equatorial coordinate, it's going to rotate the mount. Your counterweight will go it'll move it a long ways. Okay. So let me, in the attempt to move it east or west 1 degree in azimuth. Okay. I'm gonna move it east, and let's see what it does here on the chart. All right. So 1 degree east of the pole, I think it's over on this side, is going to be on this. It's going to be on this circle, right?
Yeah.
Right. And so it's going to move 90 degrees in RA to get to that 1 degree east.
Long ways.
It's going to move 90 degrees to get 1 degree. All right.
Thank goodness there's not that many interesting things up there by the.
Yeah. So that's something to wrap your head around. So let me go ahead and try it. Let me see what it does. There it goes. So now when you move it 1 degree and all of a sudden your mount starts moving a long ways in RA, you're saying, what the heck's wrong with this thing? Right?
Yeah.
You're saying, why is it moving so much? Why is my mount going to be pointing at the ground or whatever?
That far over.
It moved 1 degree, right?
Well, if it was an alt-az, it would just move that far over.
Right. But it doesn't. So that's the point of confusion on the RA and deck axis with using the path. Now let me park it again. comes right to the park position. It's going to rotate in RA. You can see the square coming, the rectangle coming back to the correct position. And then what I'm going to do is I'm going to, so that's in path where you select, unpark it. That's in park where you select the jog numbers, the jog values. All jog means is that I want to move that distance and that's it. And that's where you got to keep in mind the equatorial coordinates. Now, the other one is to set by rate. So when I set on rate, 2.5 degrees per second, okay, on the path, that means every second I hold this button down, it's going to move 2.5 degrees, north, south, east, and west. And again, that's in the direction that you're pushing. So I'm going to hold the south button down and we'll see, I'm going to zoom out a little bit. We'll see, and then I'll stop at a certain point. And then I'll move it east and west and we'll see what it does. Okay. So, okay, it just moved. See, I moved it quite a ways, pushing that button. Actually, it's not stopping. Why is it not stopping? I guess that button, I've never really played with path that much on these buttons this way, but apparently it keeps going until you stop it. So let me hit north. Yeah, it just keeps going until you hit stop at that rate. I'm going to move it north a little bit more.
Now, is that something that's set by the ASCOM community, or is that something that?
No, that's just the way this client works. So when they built this client, whoever wrote path, there's an ASCOM function called move.
Yeah.
And they say, and the move sets the rate to a certain value, and then it just leaves it there until you say stop. And that's what we're seeing in this behavior with the path. So I hit south, it moves until I hit the stop button. And then it stops. All right, so let me hit it east and we'll see if it does the same thing. I should be able to move it east at 2.5 degrees per second. And it should start to rotate in the axis around that circle, around the pole, right? That's the RA axis. It should start moving at 2.5 degrees per second this way. So let me do that. And that's exactly what it's doing. You see that it's moving 2.5 degrees per second. And then I'll hit stop. And there it is. Let me track telescope again. So if you're going to use the path hand controller, it's better to go ahead and use the rate value. They've got other rate values here that are much smaller, 0.2 degrees per second. So let me zoom up and I'll demonstrate those. Use the rate and then hold the button down and hit stop, and to position them out the way you expect it in your head to move a certain distance in that axis. So I'm going to move it north 0.2 degrees per second. You see that?
Mm-hmm.
And then I'm going to move it east or west. I'm going to move it west. See there? That's at 0.2 degrees per second.
Okay.
And then I hit stop.
Mm-hmm.
And so you can do more precise positioning that way with the hand controller on path. So you have to keep those two things in mind. So in summary, the jog works much different than the rate select type of value. If you want to do precise movements with the hand buttons on the path, use rate and select a rate that you need, and up to 2.5 degrees per second. 0.2 seems to be pretty useful, 0.2 degrees per second. But if you're going to use the jog is useful also, but just keep in mind when you're near the North Celestial Pole that it's going to try to move it physically that far. It's very useful when you're down near the celestial equator. So let me zoom down here and we'll slew over to an object just like I demonstrated before. Let me see here. Which direction am I at here? Let's go to Mars. So when it comes down here to an object, anywhere in the sky away from the pole, and you want to position it a certain distance. You can see that the coordinates now, the RA axis and the deck axis are like square to each other now, and they're not round, right? So you're further down towards the equator. So now when you move it east-west, so for example, I'm going to select 1 degree. I'm going to move it 1 degree north. Okay.
Okay.
I'm going to move it 1 degree east. It makes sense. That's what you expect. But at the North Celestial Pole, you got to remember, the coordinates get very tight. The coordinates get tight. Yep. They get tight. And so the motion is going to be much different. So I don't want to confuse anybody anymore. So I'm going to end it at that. It's something to wrap your head around and to play with.
Yeah.
You know, it's not intuitive by any means.
Right. Well, even when you set up GOTO systems in Alt-Az, I know that the math gets, you know, more and more. It needs to be really tight when you're getting around the.
Well, yeah. You run into it when you have it. So I'm going to go to Alt-Az coordinate system. Where you run into it is at the zenith.
Right.
The same thing, right? There too. On Alt-Az, the zenith is really a weird position.
If you're not doing a conversion of where you're always converting RA deck into Alt-Az, and that's how the LX200 system did work. It would run through this conversion algorithm. You know, it would still have a tough time working around the poles. You know, and you know,
that's right. So one other topic I wanted to just mention about managing a meridian flip doing astrophotography. So there's been a little bit of discussion on the forum about it. I don't want to show, I don't need to show anything. I'm just going to talk about it a little bit. So one of the things that people want to know about is, okay, I'm in the middle of an imaging run and I'm going to do a peer flip. Okay. One of the things that you do when you do a peer flip, when you're doing astrophotography, is you basically tell your system to go to the object after you pass the meridian. You go back to the object. It'll flip the mount over, called a meridian flip or a peer flip, and then you do a plate solve to reposition the object in the center of your frame. Right, you recalibrate your position of your mount. And on the PMC-8 system, if you do it too fast, let's say you've decided to do the meridian flip right at the meridian. Okay, so now it takes a minute or so to flip over to the other side, and you've slewed. So as soon as you pass the meridian and you hit slew to the object again, it will flip the pier automatically and get back on the object. But the mechanicals on your mount may not actually have positioned you there to where if you were to do a plate solve, so let's say you're pointed somewhere on the sky and you're not on the object, and you say, okay, I'm going to do a plate solve to figure out where I'm at, and then I'm going to do a sync. Okay, so if you do a plate solve and the plate solve position is still on the east side of the meridian, not on the west side, which is where you go when you pass the meridian, you go from the east to the west. If you're still on the east side and you do a sync, all of a sudden you're telling the mount now, oh, you're on the east side, right? But the program thinks it's on the west side because you did a peer flip. So that really screws up things. Okay, you've confused the mount at that point. So if you're going to do an image, and you want to do a pure flip, wait about 5 minutes, okay, before you do the meridian flip. And in fact, the PMC8 mount will let you track past the meridian for about an hour at least, depending on the configuration of your scope and your mount. If you don't, if you can actually go way past the meridian, which means if you, it's fine to be able to finish up an image, even if you're tracking past the meridian, or even do 1 or 2 images past the meridian, and then at that point tell your system, in your schedule, to go ahead and do the meridian flip. And a lot of systems allow you to delay the meridian flip until you're 5 minutes or 10 minutes past the meridian, to make sure that when you do a plate solve, that you make sure you're solving it to tell you that you're on the east side of the meridian. So that's the tip of the day for astrophotographers, is to delay their. That's much better. The other alternative is to do a pure flip early. Okay, that's the other suggestion.
Yeah.
See, I'm going to go ahead and do my pure flip early. The problem is that now you've done your pure flip early, and you have to manually position your mount back across the meridian to the east. All right, you pure flip to the west, but now you got to manually position back to the object that's still on the east side of the meridian, and that's a pain in the butt to get it centered, because as soon as you hit slew to the object, it's going to say, oh, you're on the east, or you're not on the west yet. So I'm going to go back and go flip it back over to the east. So you have to manually position it to get there, and that's really kind of a painful thing to do. So the best way to do it is, like I say, is to just let it go past the meridian 5 or 10 minutes. Take a couple more images while you're still tracking. Don't get in a hurry to do the meridian flip if you don't have to.
Right.
Wait 5 or 10 minutes and then do the meridian flip when you have a good time to stop taking images. You can do it in your sequence. If you can tell your mount to delay the meridian flip, automatic meridian flip, by 5 or 10 minutes, that's the best thing to do. I know MaximDL has that capability. Other programs should have that capability to allow you to delay the meridian flip, and then do it when it's convenient for you and you're in the middle of taking images. The system should work for you and allow you to do it the way you want, not force you to do a meridian flip. Now, that does bring up one thing. Explore stars is kind of fixed in this way. If you're visually observing an object and it's on the eastern side of the meridian, you're getting really close to the meridian, and you're really intent on looking at the object, like the moon, let's say you're watching the moon and it's getting ready to cross the meridian. Explore stars has an automatic meridian flip, to where you'll be looking at through the eyepiece and you'll be concentrating on it, then you don't realize that it's already at the meridian. Explore stars will automatically start a meridian flip, and the mount will start moving on you, and you'll back up and say, whoa, what's going on? And then you'll realize it's doing an automatic meridian flip. So Explore star, there's no switch to turn that off. It automatically does it. Just be aware of that. Otherwise, it takes care of the system for you. It'll come around and do the meridian flip and get back on the moon for you. And that's for Explore stars. So that's about all I had to cover.
Yeah. Okay. All right. I think I fixed my audio again, so
It does sound a little better.
I'll have to figure out why everything gets changed and all my settings get. I had to go back and make settings in 3 different places here. But
Are there any
hopefully
questions about?
the audio sounds good.
Yeah.
Gillis, Ollie's Astro says, I've had some issues where it conflicted with my software, with my software tool. Ended up having to turn off limits or set the limits yourself.
Yes.
Harold Locke wants to know, what other kind of maneuvers do us beginners make that cause us grief?
So that one I explained about the path, sometimes and also the meridian flip, sometimes the system will start pointing to the ground and you don't understand why. And so those are really the only two ways I know that you can confuse the system. Not with the path, but with the meridian flip. If you try to manually move it or tell it where it's somewhere else than what it really is, that's when it gets confused sometimes. But if you just keep that in mind, then you won't have a problem. Uh, if the biggest way to get back to normal, I think, in that regard, is to just let the system do what it wants to do in terms of slewing to an object. If you know you're on the east side of the meridian or on the west side of the meridian and the mount's confused, then go to an object that the mount thinks it's what side of the meridian it's on. So, for example, if the mount thinks it's on the east and you're pointing at the west, just go click on an object that's at the east and say go to that, and then that will straighten itself out. That type of thing. It's kind of hard as a software developer to read the user's mind on what he wants to do. So if the mount thinks it's on the east side and you've positioned it on the west side, or if you've let it track past the meridian, for example, we're going to allow the user to do that. It's just that subsequent moves may be confusing to the mount, and that's why it's always best to try to make it go past the meridian by itself and then try to position. It won't get confused that way. If you're trying to go back the other way, then it could be confused. If you manually position it back on the east side and it's pointed and it thinks it's on the west side, then it may get confused. It just depends on what your needs are and what you try to make it do. But you'll learn it pretty quick. You'll see it behave weird. I did have a problem early on in the development when I first released the ASCOM driver back 3 or 4 years ago, where it got confused, and it would actually, if you were tracking on an object and you slewed to the object after it passed the meridian, it would actually point it to the ground. It didn't calculate the pier side correctly. But that problem's been solved a long time ago. So if you see it point to the ground, that means it got confused somehow. Now, one of the other reasons it would point to the ground, this is one other thing that you might see, is if the system reboots. So if you're pointing at an object in the sky and you're not paying attention to the coordinates, like on the path, and the system somehow reboots itself because it got a reset on the USB port or on the serial port, or the power glitched, or something caused the PMC8 to reboot, the mount's going to still point where it's pointing, right? It's just that now the motor counts thinks it's at the North Celestial Pole. So if that's the case and you try to go to another object, or if you try to move it, it might at that point try to point to the ground, because now it's not synchronized with the sky anymore, and it thinks the object you're trying to go to is towards the ground.
Right.
The way your scope is pointed, right? So it's important to just get in the habit of, when you go to move the scope, look at the coordinates ahead of time, or look at your chart and see where it thinks the telescope is pointed at before you actually move it to the next object. That's just a good habit to get into. That way you know that the thing is not glitched and it thinks it's somewhere else that it's not.
Right. Well, okay.
Anything else? That's nothing.
There's always something else. Oh, yeah. Mike Wiesner says, Gremlins in Scott's office messing with his audio. And then they're saying, yeah, it's the tardigrades in my computer system.
Oh, yeah, tardigrades.
It could be, I don't know. Maybe it's paramecium. They're much more malicious, so I don't think tardigrades can move that fast, but paramecium, that's different. Well, that's cool. Well, we'll be back at 8 p.m. Central, so that's just a couple of hours from now, 3 hours from now. So, and we have a nice lineup of speakers for you. Again, David Eicher will be covering, the meaning of life in the universe. So, and that should be very interesting, I think. it's a big and bold, subject to talk about. So,
Yeah, it's pretty all-encompassing.
yeah, that's right. Yeah, so if you've been confused and you don't know why you're here, David Eicher's going to help you out with that. So, and I thank everybody for hanging out with us today. And Jerry, thanks very much. We hope to see you tonight if you're able to make it. And
I'll try to make it. I think
okay.
I'm going to try to image the moon.
Very cool. Okay. All right. So also we have Cesar Brolo coming on, as I might have mentioned. Pekka Hautala will be on. Cameron Gillis will be on. Living the Stars will be on as well. And maybe one or two more. So we'll see you. And if you're at all inclined, I think we'll end maybe a little bit earlier than we have at some other Global Star parties. Like, for instance, the Saturday Global Star Party went almost to 2 o'clock in the morning.
It's pretty late.
So that was pretty late, and we did have people join in the after party, but they were going, they didn't sign up to be up that late. So, but that's
you had a lot of speakers on. I noticed that you just had a lot of people.
Yeah. Sometimes when we have a special guest host, they pull out all the stops and they get all the speakers, that they'd love to have. And so that worked out really well. But it makes for a longer event. And in fact, I think it was our longest event because we broadcast for 7 hours straight. So
yeah, that's a full day seminar. Think about
it. It's a full day. That's right. So, yeah. All right. Well, thanks, everyone. And we'll see you soon. Okay. Take care. So we're going to show you the PMC line in the Exos 2 and the G11 system. G11 is the classic mount made by Scott Wasmandy out there in California. We've got it modified, though, with a PMC-8 system that has the stepper drives on both axes. This is a wired configuration. I have a NUC computer here running the whole system. It's running all my camera control software. It's running the SkyMap software and everything, also to run the PMC-8. In the back, we've got the telescope drive master that takes that plus or minus 5 arc seconds that Wasmandy guarantees down to 1 arc second or less periodic error. You can see I'm holding the electronic box here, and I'm going to mount that. I have a special mount that I built where I'm going to mount it to the leg. But to show you the other parts of the telescope, we've got an Optec electric focuser that's mounted onto my ED102 carbon fiber. I've got an ED80 here. Now, you might think this is too much mount for these little telescopes, but I'll tell you that when we're using this out in wind or in adverse conditions, or anything. I mean, this thing is the Rock of Gibraltar. So
you can't have too much mount.
That's true. That's true. And let's learn more about what you got over here.
So over here, I've got our Exos 2 with PMC-8 system, which is the same exact controller as on the G11. The same stepper motors, both on the RA and deck axis. On the mount, we have a Essential Series 127 telescope. This telescope also comes in a ED80 version and a ED102 version. and it's a spectacular mount. This is a configuration that I use when I go to star parties.